All right, everyone, welcome to the final solution video for while loop worksheet 1, where we're going to be looking at the Fibonacci number. If you don't know what the Fibonacci number is, think of it as a function, where if we're interested in the Fibonacci of n, it would be equal to Fibonacci of 1 prior and 2 prior. So Fibonacci of 0 is 0 and Fibonacci of 1 is 1, and that is our two given values, two assumed values for n of 0 and n of 1. So if we were interested in Fibonacci of 2, it will be the sum of Fibonacci of 1 and 0, 1 prior and 2 prior. So Fibonacci of 2 would also give us a value of 1, and we're going to be programming that code here. So let's get our input first. So we want the nth value for num. We're going to get an integer input, entered value for n, and we're going to do some processing and output. To make our lives easier, I'm going to create some base cases. So we have base cases that Fibonacci of 0 is 0 and Fibonacci of 1 is 1. So since we don't need to do any computations for those, I'm going to be writing some base cases there by saying if num is equal to 0, we're going to print 0. If num is equal to 1, we're going to print that the Fibonacci number is 1. So those are easy cases that we're going to set aside and quickly output. And we're going to say else. This means that our num is greater than 1. So starting off, that's what we're going to do. And now I'm going to set up some variables so that it can help us calculate the Fibonacci number. So we're interested in fib of n. So we're going to say fib of 1 is equal to 0 and fib of 0, 0, fib of 1, 1. So I have the first two Fibonacci numbers set, and I'm going to be updating this variable called fib of n to be fib of 0 plus fib of 1. Now, our code is not done yet. This is just the setup that I'm going to utilize in our program as we go along. So we need a location counter because we're looking at the nth location. So let's call it nth location. And we're going to start at 2 because I already have the 0 is the first. So I'm going to now look for the second Fibonacci number. So we're going to say, well, while our nth location is less than and equal to our num, where the value that we're trying to get. Then we're going to say, well, fib at that location is equal to fib of 0 plus fib of 1. Therefore, I don't need to do this, but rather initialize this to 0 because I'm going to be updating that variable now instead of doing that calculation outside the while loop. Every time I do that, I'm also going to say fib of 0 is fib 1, and fib of 1 becomes the new fib of n calculated, and then we're going to go nth location plus equal 1. But every iteration, we're increasing nth location to go towards num. And every iteration, we're calculating the Fibonacci at that new location, or the nth location. Once we find that, we need to set up so that we can now do this for the next iteration by updating fib of 0 to be the current fib of 1, and fib of 1 is going to be updated with our newly found Fibonacci of n. So after this while loop is finished, end of while loop, we're going to say print Fibonacci at num. Actually, let's write that all in one line. Is fib of n. Okay, our code is done. I've updated line 15 and 17, and we'll be now testing our code. Let's test out our base case of 0, and we get Fibonacci of 0. If we're to run again at Fibonacci of 1, we get 1. Now let's check some other values. We should test 2. That should be 1, because 1 plus 0, that gives us 1. So Fibonacci of 3 be expected as 2. And Fibonacci of 4, 3. And Fibonacci of 5 should be 5. Now it's getting interesting. Fibonacci of 6, the 8, which is 5 plus 3. Then we're going to go 5 plus 8 for 7 to give us 13. So this is the solution for Fibonacci numbers. It was probably one of the more complex problems that we have solved so far, but now you can see that we're now starting to ramp up the complexity of the problems that we solve. Thank you for watching and stay classy.